ByteDance has introduced a model called GOKU that combines image and video generation in one place, and it appears to be pushing boundaries in ways that could challenge OpenAI's Sora. This development arrives at a moment when Chinese AI is displaying increasingly advanced capabilities, and GOKU is powered by rectified flow transformers, which differ from the diffusion approaches that many models rely on. These rectified flow methods interpolate data in a smooth, linear fashion, aiming for more stable trajectories from noise to fully generated content. ByteDance reports that GOKU supports text-to-image, image-to-video, and text-to-video, and that it can create realistic, photorealistic human interactions, complex motion, and intricate scenes with multiple objects or dynamic lighting. There is an emphasis on how GOKU is trained. The team has gathered a huge data set of 160 million image-text pairs and 36 million video-text pairs, curated through a pipeline that uses filters such as aesthetic scores, optical character recognition checks to exclude clips with excessive text, and even motion filtering to ensure that each clip has a balanced amount of motion. They also use captioning models, including Intern VL 2.0, Tarsier 2, and Quen 2, to provide descriptive text for each image or video clip, which helps the model learn how textual prompts map onto visual features. The entire training process is multi-stage. GOKU first learns text-image alignment, then trains on images and videos together to unify knowledge across both domains, and then undergoes modality-specific fine-tuning for either images or videos. During that process, the resolution starts at 288 by 512 before moving up to 480 by 864, and eventually to 720 by 1280, so the model can gradually learn to handle greater detail. Rectified flow transformers are central to GOKU's advantage. Rather than the denoising strategies seen in typical diffusion-based systems, GOKU predicts velocities that move intermediate samples along a path from noise to real data. ByteDance's pilot experiments suggest faster convergence compared to standard diffusion methods, as shown in proof-of-concept tests on ImageNet 1000, where GOKU reached better FID and inception score in fewer training steps. Another significant factor is the infrastructure ByteDance uses to train it. They rely on advanced parallelism strategies such as sequence parallelism, spreading sequences across GPUs, fully sharded data parallelism, splitting parameters and gradients across data parallel ranks, and fine-grained activation checkpointing, which cuts down memory usage. There is also Byte Checkpoint for quick saving and loading of training states, plus fault tolerance from Megascale that detects system failures and resumes large-scale training with minimal downtime. These methods are critical for a model that can handle long sequences exceeding 220,000 tokens. ByteDance has published results showing that GOKU excels on text-to-image benchmarks like GenieVal, T2 iComp Bench, and DPG Bench. On GenEval, for instance, the 2B perimeter variant scores 0.70 without prompt rewriting and 0.76 with rewriting, while the model also reaches 83.65 on DPG Bench. On text-to-video tasks, GOKU secures an 84.85 on VBench, surpassing other industry players such as Cog Video X5B, Kling, Pika, and Hunyun Video. Evaluations on the UCF 101 dataset indicate that it achieves lower Friche video distance and higher inception score, implying more coherent videos. Additional ablation studies show that larger variants like the 8B parameter model reduce distortions and produce more stable motion, while training both images and videos in one model helps produce better results for complex tasks. The model can even handle image-to-video transformations, where the first frame is a reference image and the user can prompt the system to animate it into a short clip. Some observers see GOKU as part of a broader story that open source AI is outpacing efforts to control AI technology with regulation. Open source models like Llama have already indicated that trade barriers cannot fully restrict this technology. GOKU's development under ByteDance, a major Chinese tech firm, could shift perceptions of who leads the AI race. That unsettles some US regulators, especially in the context of the rumored hostile bid by Elon Musk affecting OpenAI's leadership. The friction between proprietary and open source models has also become more visible. Meanwhile, companies outside the AI labs are finding that the real source of value lies in how organizations implement these models. High-level creativity alone does not always solve business needs, since an AI might produce 20 workable ideas, but the operational difficulty comes in selecting the most viable one and adapting it to real-world workflows. AI literacy is key for that process, and it extends beyond executives to marketing teams, product managers, and developers. Concerns about deepfakes keep growing as well, because GOKU and similar systems can generate hyper-realistic videos and imagery. ByteDance's advanced methods for ensuring smooth motion and detailed backgrounds create scenarios that can be exploited for misinformation or identity theft. Researchers emphasize detection systems and a certain level of public skepticism to counter these threats, but the underlying feeling is that open-source AI technology becomes harder to contain, so building a more AI-aware society is crucial. In an academic context, eCornell's Designing and Building AI Solutions certificate program highlights the importance of these cross-industry AI issues, so that new developers and entrepreneurs can integrate machine learning models responsibly. Another highlight is the emphasis on ByteDance's unique data balancing scheme. They employ a classification model to tag and distribute videos across 9 core categories to ensure that humans, animals, scenery, and other semantic segments appear in balanced proportions. That approach addresses the complexity of modeling realistic human behavior, which is often trickier than generating landscapes or cartoon scenes. The pipeline discards a significant amount of content that does not meet certain thresholds. For instance, for 480 by 864 resolution data, clips with an aesthetic score below 4.3 or motion outside the 0.3 to 20.0 range are removed. Thresholds become even more rigorous for 720p or higher. A system like Tarsier 2 includes built-in camera motion descriptions, so GOKU can adapt its generation to prompts like zooming in or panning right. The motion score gleaned from raft-based optical flow computations can even be appended to captions, allowing the model to better handle motion extremes. When GOKU was tested for zero-shot generation, the results revealed that it can create competitive visuals without fine-tuning on specific subdomains. Beyond that, GOKU is pitched to unify both images and videos inside a single architecture by combining a 3D VAE with full attention blocks, 3D rope embeddings, QK normalization to stabilize training, and patch and pack to handle sequences of varying aspect ratios and lengths. The largest version, GOKU 8B, employs 40 layers, a 3072 model dimension, and 48 heads. Another smaller variant, GOKU 2B, includes 28 layers, a 1792 model dimension, and 28 heads, with both targeting commercial-grade image and video generation tasks. ByteDance's official pages for GOKU show short demos where text or an image prompt sets off a sequence that looks nearly cinematic. They also show references to expansions that unify the entire pipeline, from low-resolution placeholders to fully upscaled frames with crisp detail and lifelike human motion. This leads into possible marketing uses, high-end productions, or short video social media campaigns where creative directors see how GOKU can accelerate visual idea generation. Some mention that the cost of video production drops when a large model can produce multiple polished previews, which can then be refined by human teams. However, like every generative model, GOKU is only as useful as the workflows that integrate it into marketing or customer-facing experiences, so literacy in prompt engineering or model strengths remains key. Some watchers see this as a direct pushback against OpenAI's Sora model, especially given ByteDance's track record of success with platforms like TikTok. The tension with US companies is evident. The open source aspect adds to the challenge of regulation because once a strong model is released, it becomes extremely difficult to stop it from spreading. The references to Sam Altman, Elon Musk, and the US government's attempts to contain AI technology highlight a rapidly evolving landscape. In that environment, GOKU's sophisticated training design with advanced concurrency and parallelism, plus byte checkpoint for more efficient state management, sets a high bar for others building next-generation models. The real differentiator might be the combination of large data, a powerful architecture, scalable infrastructure, and flexible cross-modal training that merges images and videos. GOKU is a big move in the AI race, showing ByteDance's push to stay ahead. But pumping out endless videos isn't enough. Businesses need smart strategies too. Open source models like GOKU will likely grow alongside commercial ones, cutting costs, sparking creativity, and making AI literacy more important than ever. All right, thanks for watching, and I'll see you in the next one.